Yes, sir. Visible, sir.
Okay, I'm going to log in mobile also so that if someone will join, I can come in. One second. Someone is joining. Yeah, hello. Voice is audible? Can anyone reply?
Yes.
Okay, okay. So this is the first question I have completed. Echo is coming because of the. Hello. Okay, now it's okay. So this is the first question. This is a full bridge rectifier circuit. So here source voltage is 230 volt, 50 hertz, and output side a RLE kind of load is there. Okay. So RLE load means separately DC motor we can model as RLE. So in DC motor resistance will be there, inductance also will be there, and one back EMF will be there. So a load is given which is in RLE load, DC motor load. So they are asking that the DC motor load is like it is electrical braking. Okay, so we are doing the electrical braking of the motor, and inductance is sufficient for the ripple free current. Means in this the current will be constant. Okay, so firing angle of the bridge circuit for a load current of 10 ampere. So this we have to calculate. Okay, so braking means motor will supply current back to the source. Okay, so let's say I am assuming this as a output voltage. This will be VO. So in this loop we can write the KVL equation here. So the KVL equation will be, here we can write the KVL. So KVL will be minus V naught plus 2I I naught minus 150. This will be equal to 0. Then V naught will be, I naught already given. So 2 into I naught it will be 20. So V naught will be minus 130. 20 minus 150 it will be minus 150. And for full bridge converter we already know the formula, 2 Vm upon pi into cos alpha. So this should be equal to minus 130. So here we can calculate the value of alpha. Okay. So alpha will be cos. So Vm will be here. Here this is RMS value. So Vm will be 230 into root 2. Okay. So cos alpha will be minus 130 into pi divided by 2 into 230 into root 2. Here we can calculate the value of alpha. Can anyone calculate? I am also calculating. So this will be cos inverse minus 130 into pi divided by 2 into 230 into root 2. 128.88. Is it clear?
Yes, sir.
C will be the correct option. See. So whenever the constant current load will be there, in that case, this formula will work. 2 Vm upon pi into cos alpha. This will be the average output voltage. Okay. So that average output voltage will appear here, and we can write KVL in this one. So this way we can say that the battery is supplying current back to the source. Okay. So during braking, what will happen? The battery, here the battery terminal is reversed. What we are doing initially, one second.
Load to source, sir.
Yes.
Battery terminal reverse means load to source, no, sir. Current direction.
Load to source will be supplying.
But here inductor doesn't allow sudden change current, no sir.
Okay, so this current will be in this direction only. See, this already we have reversed this terminal. Okay, already this terminal is reversed. So initially motor will be like this, R L E. This will be the motor equation, motor modeling. Okay, so during braking what we are doing, we are just reversing the terminal of the motor here. So E, we can see that E is reversed here. So E will be reversed means we will supply in this way.
One second.
Now is it clear now? See, normally DC motor will be like this. Okay, plus will be here, minus will be here. But during braking, what we are doing, we are just reversing the terminal such that so minus will be at top, plus will be at minus, and this will supply back to the source. Okay. So actually, already this thing is given in the question. So asking that what will the firing angle. So current here it is going means this machine is supplying back to the source. Is it clear now?
Yes sir, clear sir.
Okay. Okay. So I'm moving to the next question. This is I think recent question only asked in the gate. So how we can approach this question? A full bridge rectifier circuit is given. Alpha is 120 degree, and already this source voltage is given. R is 20 and E is 800 volt. So already here also current is ripple free. This output current is ripple free. So power fed back to the source. So we have to calculate power fed back to the source means how much power will be fed back from here. Okay. So here power fed back to the source in the kilowatt. So E is 800 volt. R is how much? 20 ohm. So we can calculate the output average voltage here. How much is the voltage? So 2 Vm upon pi into cos alpha. How much? 2 into Vm how much? 200 pi divided by pi into cos 120. How much? How much this value? So it will be 400 into cos 120. 400 into cos 120. So minus
200
2,
sir.
minus 200.
Minus 2.
So minus 200 means here it will be plus and here it will be minus and the magnitude will be 200. Okay. So if we will write KVL in this loop, what will be the current here? 800 minus 200 divided by 20. So 400 divided by no 600.
600.
600 divided by 200. 20.
20 sir, that one.
So this will be 30.
30.
So current in this will be I naught will be 30 ampere. So what will be the power fed back to the source? Power fed means here we have to calculate the power. So power will be 200 into 30. So it will be 6000 watt. But it is asking in kilowatt. So answer will be 6. So every time we have to see the unit. What unit they are asking. Okay. In fill in the blanks type question, we should be always careful with the unit. Sometimes they will give something in the question, they will ask different unit. So here we can, this is a probable type of mistake. Like suddenly if I will fill 6000, that will be a wrong answer. So you have to be careful. 6 will be the correct answer for this. Is it clear to all?
Clear sir.
Okay. Moving to the next question. So this is asked in 2018. See, some rectifier circuit is given. We don't know what is the rectifier circuit, but they have given the equation for that rectifier circuit. So already they have given the equation. What is the equation? Vo is equal to Vm upon 2 pi 3 plus cos alpha. Okay. And Vm value they have given in 80 pi. Alpha is the firing angle and power delivered to the lossless batteries is 1600 watt. So here we are charging the battery. Okay. So power delivered to battery means what we can say, this here some current will be there. So I into 80, this is 1 second, wait, someone is trying to join. 1 second. Hello. So the current will be how much? 0 0 will cancel, so I will be 20 ampere. Is it clear? Power delivered to the lossless battery is 1600 watt, means some current will be here. So that current into watt, this 80 what is this? 1 second. So V into I, this would be equal to 1600 watt. So current will be 20 ampere. Up to now is it clear to all? So now we can calculate this voltage. So that voltage will be 20 into 240, 40 plus 80, how much? 80 plus 20 into 2. So 80 plus 40, 120 volt. Okay. So this DC
But
was,
that VM is 80 pi na, sir.
no, no, I'm not using VM here. VM we will use later. Okay. See, what is given in the question? The power delivered to the lossless battery is 1600 watt. Okay. So this is the battery. Power delivered to battery means this is battery. Current flowing through this, but some current will be there. So this is 80 volt. What will the power delivered to the battery? 80 into I. So 80 into I is the power delivered to the battery. This should be equal to 1600 watt. Okay. So
Okay,
here we
sir.
can calculate the charging current. Charging current is 20 ampere. Is it clear?
Yes,
This,
sir. Yes, sir.
further we can write KVL in this loop. Okay. So KVL we can write minus V naught plus 2 into I plus 80 is equal to 0. So V naught will be 2 into I means 40. So 40 plus 80 will be equal to 120 volt. Okay. And already this equation is given, output voltage equation. So Vm upon 2 pi 3 plus cos alpha, this should be equal to 120. From here we can calculate the alpha value. Okay. So Vm upon 2 pi means 80 pi upon 2 pi 3 plus cos alpha should be equal to 120. So this will be how much? 40. So cos alpha will be 0. 40 3 times. So 3 plus cos alpha is equal to 3, and cos alpha will be 0. So value of alpha will be 90 degree. Is it clear? See, one thing I will try explain here. Here they have written up to 2 decimal. Up to 2 decimal places. First answer we are getting in integer. Okay. So we have to note, it's not required to like confuse, like they're asking in decimal, so answer should be in decimal. Sometimes they will ask, they will simply put this, like in the question if answer will be integer also, they will simply put this thing, this message. So no need to confuse about this. Like if our answer is in integer, then put the integer value. Okay. Like sometimes we will get confused, like if they are asking in decimal, answer should be in decimal only. We are doing some mistake, like that thought will come. But see, here they are asking up to 2 decimal, but our answer which we are getting is integer value. Okay. So sometimes just they are copying pasting this message in all the questions. We don't need to think about this. If we are getting integer value, simply we can put integer value. Is it clear?
Yes, sir. Clear, sir.
Okay. So moving to the next question. This question is asked in 2015 gate. It's a good question. So three diodes are there and one thyristor is there. Okay. So we are asking what is the average voltage across resistance in volt under the steady state. So I am going to draw the voltage. First we can draw the input voltage. So source voltage is a sine wave. Okay. And here I am to draw the output voltage V0. So at alpha we are triggering this, alpha is equal to 30 we are triggering. So after 30 this will be the voltage. Okay. And here both two diodes are there. So diodes are there means here it will be a full cycle like this. This is alpha, this is pi, this is 2 pi. Again it will repeat like this only. So this is the one whole cycle here to here. So alpha to pi, T1 D2 is conducting, T1 D2, and pi to 2 pi D3 D4 is conducting. Is it clear to all? Output waveform. Can anyone reply?
Yes, sir.
Okay. So here this is the one cycle. One full cycle is alpha 0 to 2 pi is the one full cycle. Okay. So here we can average voltage will be 1 upon 2 pi integral alpha to. So see here two parts are there. So I am going to write the two parts separately. So here only we can do mistake. So alpha to pi Vm sin omega t d omega t plus here pi to 2 pi, here it will be minus Vm sin omega t. See, this will be a reverse of this one. So here it will be a minus Vm sin omega t d omega t. Is it clear to all this equation? Here only sometime we can do mistake. We will simply put plus sign, but it will this waveform is a reversal of this. Okay. So here to here it will be a minus Vm sin omega t, and here to here it is the same waveform. This one, so it will be a plus Vm sin omega t. Is it clear? Here it will be 1 by 2 pi. So Vm I am taking comma Vm upon 2 pi. Okay. And cos omega t integral will be minus sin omega t. So here it will be minus cos omega t alpha to pi plus here it will be cos omega t pi to 2 pi. Is it clear to all? Can anyone reply?
Yes, sir. Yes, sir.
Okay. So Vm upon 2 pi, here cos of pi will be minus 1 and minus plus 1. So plus 1 plus cos alpha, here cos 2 pi will be 1 and minus cos pi will be 1. So this will be Vm upon 2 pi 3 plus cos alpha. So this will be the equation of the output voltage, average output voltage. Simply we can put the values. So Vm is 100 upon 2 pi 3 plus cos 30. So this we can calculate 100 upon 2 into pi to 3 plus cos 30. So 61.52. Everyone is getting this answer? 61.52 volt. So this is also fill in the blanks type question. Their unit is volt. So answer will be 61.52 volt. Is it clear?
Sir,
Yes, you can ask.
in place diodes, we have thyristors. In thyristor, one diode, sir.
One thyristor is there and three diodes
Ah,
are. You want
extra
to
question,
analyze some
sir.
other case?
Other case, sir. Three thyristors, one diode.
One second. This one. You want to analyze three thyristor and one diode like that.
Yes, sir. In that case, Vm by 2 pi, 1 plus cos 3 alpha, sir. I think
Okay, we
answer.
can analyze, no? Whatever the case will be there, we can analyze.
Okay, okay.
Okay. So you are saying that one diode, like that you are telling.
Yes, sir.
So which I should take the diode? This one, first one. Let's say first one only.
Third, second, third one, sir. Third one.
Okay, this one I
Third
am
one
taking.
diode.
This one I am taking
Ah,
as diode. Okay.
okay, sir.
So T1, T2, and D3, T4. Okay. So here also at let's say alpha we are firing T1, T2. Okay. So this is the source voltage. At alpha we are firing T1, T2 here. So it will go up to here. Okay. So it should be same one. Let's see T4 if we will fire. So it will be same only, like not like previous case. It will be like this one.
Yes, sir. Yes, sir.
Hmm? Let's say at alpha I am firing T1, T2. So this will go at pi, it will be 0. Again, till I will not fire this T4, this will not conduct, diode will not conduct. So here I am firing T4. Okay. So this will be same as semi converter, Vm upon pi 1 plus cos alpha. This will be a semi
Okay.
converter case.
Sir, if T3, T3, T4 diode, sir.
For resistive load, see, this is for resistive
Ah,
load.
yes, sir.
You can ask T3.
I mean, in D3, D4, sir. If we replace D3, D4.
Okay, this I should replace with diode.
Ah, yes, sir.
Okay. So this is also same. Na? Here also it is same. I think. No. Okay, two thyristors are there and two diodes are there. You are telling, na?
Ah, yes, sir.
1 second. Can do. So T1, T2, if we are firing here, will conduct up to here. T1, T2. Again, here automatically it is D3, D4 will conduct. So it will be same only. See here what is the there? T1 if we are firing, T1, D2 is conducting up to pi. After pi, automatically pi to 2 pi, this D3, D4 will conduct. Here also, alpha to pi, this T1, T2 will conduct. Okay. T1, T2 we are firing. Again, after pi, this D3, D4 will conduct. So output voltage will be same here. Is it clear?
Okay, okay, sir.
It will be same only. Just we have to, at this only we have to analyze. Like in positive half cycle, this T1, T2 is conducting up to pi. See, if I will replace one with diode also, na, then also it will be same only. T3 if I am T2 if I am replacing with diode, then also it will be same only. But since T1 I am firing, T1 and D2 will conduct. Again after pi, D3, D4 will conduct. Is it clear?
Yes, sir. Yes, sir.
But
Clear.
this is for resistive load. In case of inductive load, something else will happen.
Okay, okay, sir.
Okay. Okay. So I'm moving to the next question. This is the next question. A simple diode bridge rectifier is there. So here a 10 ampere constant current source is there in the output circuit, and it is asking that if we want to replace the current source with a resistor so that the RMS value of the current supplied by the source voltage remains unchanged. Okay. So whatever the RMS value of the current IRMS, here output 10 ampere current is there, so some RMS current will be supplied by the source. If you will replace this by a resistive load, this current should be same. So what will be the value of that resistive load? What will be the value of that R load? So how we can calculate this one? What is the RMS current in this case? Can anyone tell? If output current is 10 ampere, what is the source RMS current? Can
10
anyone tell?
amperes only, sir.
It will be 10 only. It will be a square wave. Yes. Source current will be a square wave. Magnitude will be plus 10 minus 10 and RMS value will be 10 ampere. In second case, what will be the RMS current? So that will be, so output current I am drawing in second case. The output current will be like this one. Okay. And what will be the source current? Source current will be like this one. Is it clear to all? So when constant current will be there, this is the source current waveform. This is the output current, constant current, and this is the source current. This is I not Is. Here it will be I not current. This is the source current. Is it clear to all? Case of resistive load. This magnitude will be V naught by R. Peak will be V naught by R. No, not V naught by R. Vm sin omega t is the source voltage. No? So output voltage will be like this. So Vm by R. Is it clear to all? Otherwise, I will explain again.
Sir,
Right.
V not average by R, sir. That one.
Not average. See, I am just drawing the waveform. So source voltage is Vm sin omega t. This is the source voltage. What will be the voltage waveform across load? So across voltage current waveform will be V naught Vm by R. Peak value will be Vm by R. This is the current waveform, not average current. This is the current waveform. So this is, since
Okay.
output waveform is this one. So when this D1 D2 will conduct, then source current will be this one. Okay. And when D3 D4 will be conducting, the source current will be reversed.
Negative offset. Ah, yes, sir.
Here also same thing is happening. So here this is the source current Is.
Yes,
So
sir. Yes, sir.
what will be the RMS value in this case? Output RMS and source current RMS. It will be same only. Vm upon Im upon root 2. It will be correct? Im upon root 2. So
Sir, I am.
Vm upon root 2 R. This will be the RMS value of the current, source current. Is it correct? Here.
Yes, sir.
So this only we should equate with this 10 ampere. They are asking that what will be the resistance value such that the RMS value of the source current will be same as this case. So this case RMS value is 10 ampere. So for resistive load case also this would be equal to 10 ampere. So from here we can calculate the resistance value. So R will be Vm how much? 230 into root 2 divided by root 2 into 10. So resistance value will be 23 ohm. So if we will connect a 23 ohm resistance here, in case of this current source, so that case also the source current RMS value will be 10 ampere. Is it clear to all?
Yes, sir. Yes, sir.
Load current current
Your voice is not audible. Can you repeat again? Hello? Your voice is breaking. One second. Can you write in chat box? Your voice is not audible. Hello?
Hello, audible sir, I am sir.
Now it's audible. You can tell.
सर अगर रोड में करंट सोर्स है तो वो जो वैल्यू होगा वो आरएमएस वैल्यू ही होगा सर कि
Source current का. Still voice is breaking. Can you repeat once again? His voice is audible to other person?
सोर्स है
No, sir. Not audible, sir.
A little bit breaking, I think. You can ask again.
ओके सर आई आस्क यू लेटर सर
See, again I will explain here.
सर रोड
It's very simple
Okay.
question. Like in both case, we have to equate the RMS current. So one case is output side. The load is a constant current, highly inductive load. Case one. This is the case one. Okay. So when highly inductive load current will be there, in that case the source current RMS value will be same. because source current waveform will be a square waveform. Here this is pi, this is 2 pi. Okay, so this is the source current waveform in case of this case. So if we will replace this load with a purely resistive load, okay, so in that case what will be the load current? First we can say load current will be the this one. First load voltage, what will be the load voltage? That will be like this, full rectifier. So this will be Vm. Load current will be Vm upon R. Load current waveform will be, this peak will be Vm upon R, this resistance value. So here we can see that this, let's say D1 and D2, D3, D4. So D1, D2 will conduct here, D1, D2, D3, D4. Okay, so here we can see that if D1, D2 will conduct, so this is what is the source current? If here D1 and D3, D1, D2, D3, D4, this D3, this is D4. So ID1 minus ID4. Okay, so this is ID1. One second. Here to here it is ID1, here to here it is ID1, and here to here it ID4. So ID1 waveform will be here to here, and ID4 waveform will be here to here. So if we will do ID1 minus ID4, so that will be this kind of waveform. Okay, this is ID1 minus ID4. ID1 will be like this, 0 to pi. ID4 will be pi to 2 pi. Magnitude will be Vm upon R, Vm upon R. Okay, so actual source current waveform will be like this one. Magnitude, amplitude will be, one second. One second. Magnitude will be Vm upon R. So here also magnitude will be Vm upon R. Okay. And what will the RMS value? Vm upon root 2. Is it clear to all now? Same as previous case. Here constant value was there. Then also it was, we were making negative, and here this rectified waveform are there. So in this case it will be negative. So ID1 minus ID4. Is will be ID1 minus ID4. Is it clear to all now? Can anyone reply?
Clear, sir.
Okay, okay. Okay, so I'm moving to the next question. So here a single phase semi converter circuit is given. Okay, 230 volt 50 hertz AC supply is there, and firing angle of the converter is 5V4, 45 degree. So load on the converter is highly inductive and resistance is 17.675. So we have to calculate the RMS value of the freewheeling diode current and RMS value of the fundamental value of the source current. Okay, so first I am going to draw the circuit. The circuit will be this kind. Resistors will be there. Okay, and here a freewheeling diode is there. So this is a circuit of a semi converter, and load is highly inductive and resistance is 17.675. 17.675. So we have to calculate RMS value of current in this freewheeling diode. So first we can calculate the average output voltage. So average output voltage will be Vm upon pi 1 plus cos alpha. This is for semi converter. So Vm already is 230 is given, so 230 into root 2 divided by pi 1 plus cos, how much? 45. So how much it will be? Can anyone calculate? I'm also calculating. So 230 into root 2 divided by pi into 1 plus cos 45. 176.74. Is it correct? 176.747. So what will be the current, output current, divided by I naught is equal to V naught by R. So this will be divided by 176.675 divided by 176.675. So almost
10 amperes.
10 ampere. current is 10 ampere, what will be the freewheeling diode current? So if you see the waveform, so 0 to alpha, alpha to pi, and pi plus alpha to 2 pi. So freewheeling diode will conduct here and here, okay, and source current will conduct here and here. This is the source current waveform, and freewheeling diode will conduct 0 to alpha and pi to pi plus alpha. So IFD RMS will be I naught into under root 2 alpha by 2 pi. So I naught into under root alpha by pi. IFD RMS. I naught already will
Option D, sir.
How much you are getting? 5 ampere.
8.66.
First question.
Ah,
How much you are getting? This is 10 into alpha. How
10
much?
amp.
45 divided by this is 180. How much? So this is 4 times. 10 into 1 by 2. So
5 amps.
10 into
5
5 ampere.
5 amps, sir. First answer 5 amps.
First answer will be 5 ampere. C. Similarly, we can calculate the, already I have told what is the fundamental value formula. So fundamental value formula is, already you know, 2 root 2 upon pi into I naught into cos alpha by 2. This is IS1 RMS value magnitude. Okay, for this question. The RMS value of the fundamental source current will be, okay. So here we can calculate 2 root 2 upon pi into I naught how much? 10 into cos 45 by 2. So this will be the value of the fundamental value of the RMS current. RMS value of the fundamental source current. I am also calculating 2 into.
Sir, option D, sir. 8.66
D will be
amps.
correct. 8.66. Maybe it will get little bit less. I think 8.3 or something will get, but this is the
Yes, sir.
nearby.
8.33, sir. 8.33.
8.3 we are getting, but this is the nearby option, so this will be the correct. Is it clear to all? Clear to all? Should I move to the next question? Can anyone reply?
Yes, sir. Yes, sir.
Okay.
Yes, clear, sir.
So this is the next question. Here single phase full bridge converter is given, freewheeling diode. So same, it is a semi converter. When single phase full bridge converter will have a freewheeling diode, it will be a semi converter. Okay. And load resistance is 15.53, and large inductance means, and ripple free current. Okay, means output current we are assuming as constant. The input to the converter from, we are supplying a 230 volt 50 hertz voltage, and for 60 degree, what will the RMS value of the fundamental source current? Similar kind of question, just calculation we can do here. So 2 into Vm upon pi, 2 into, no, here Vm upon pi 1 plus cos alpha, that is semi converter. So output voltage will be Vm upon pi 1 plus cos alpha. Okay, so Vm how much? 230 into root 2 divided by pi 1 plus cos 60. How much we are getting?
232.956 volts.
1 second. 230 into root 2 divided by pi into 1 plus cos 60. How much? 155 we are getting? 155.3.
155.304 volts.
155.304.
Hmm.
So what will the output current? If you divide by 15.53, I think here it will also be 10 ampere.
10 amperes.
10 ampere. Okay. So what will be the fundamental value of the source current? So that will be 2 root 2 upon pi into I naught 10 into cos 60 by 2 is equal to cos 30. Okay. So 2 root 2 divided by pi into 10 into cos 30 root 3 by 2.
7.79 amps.
7.79.
79.
7.79 is correct answer. So So can we calculate THD also here? What will be the THD? THD for
IS
total number of bits.
IS1 by IS, sir.
We can calculate and check what will the value THD. So IS1 we already know 7.79. What is the IS value? IS will be pi minus alpha divided by pi into I naught. Okay. So this will be how much? Pi minus pi by alpha is how much? 60 degree.
60 degrees.
So it will be pi by 3. 60 degree is pi by 3. So pi minus pi by 3.
8.164 amps.
So this will be 2 by 3 into I naught.
Yes, sir. Yes, sir.
Okay. How much you are getting?
8.164 amps.
8.164 ampere. Now we can just calculate this IS1 by IS. How much we are getting?
7.7 by sir, 0.954.
0.954. So THD will be 1 by AF square 1 by 0.954 square minus 1. This will be the THD value. How much it will be? 1 by 0.954 square minus 1. 31.4%. You getting?
Yes, sir. Yes, sir. 31.42%.
Okay. So question can be framed like this, like indirectly also they can ask. Sometimes they will give the THD. Okay. Sometimes reverse data also they can ask. Like THD will be given, from the THD data we can either one of this data will be given. Okay, let's say either source current. So from THD also we can calculate the fundamental source current. Okay. So that kind of question also can be framed. Sometimes we are asking THD, but THD will be given in the question. So from this THD data, we can calculate the fundamental this one IS1 like that. Okay. So should I move to the next question?
Yes, sir.
Yes, sir.
Okay. So this is also a same type of question, like the semi converter only. First I am going to draw the circuit. Just a lengthy, it's looking big but it's easy only. This is a resistor network. All of you can go through the question. Just I am drawing the circuit. So load is RLE. R is 5 ohm. L is 10 millihenry. And E is how much? 80 volt. And freewheeling diode also will be there. Okay. So what is the given the question? Alpha is 50 degree. Alpha is equal to 50 degree. This is 230 50 hertz. Okay. So for continuous conduction, a converter is operating with continuous conduction means we can say that output current is constant. If one of the main SCR is damaged, open circuited due to a fault, then the value of average output current on the assumption of continuous conduction. So this type of language will be given. In that case, we can assume that the output current is continuous and ripple free. Okay. So let's say this thyristor is damaged. This thyristor is damaged. So what will be the output voltage waveform that I am going to draw? So this is source voltage. Okay. At alpha we are firing this T1, T2. So alpha 2 here voltage will appear, and here since one of the thyristor is gone, so reverse voltage will not appear. Even if it will be fired also, this will be open circuit. So what will happen, since output current is constant, so that will flow through this freewheeling diode only. Okay. So when freewheeling diode will flow, this output voltage will be zero only. So only this waveform will appear across the output. This will be the output waveform. Is it clear to all? Otherwise, I will explain again. Can anyone ask? This is
Clear, sir.
case of full, like if it fault will not be there, this waveform will appear here also. But since fault is there, because of fault, this voltage will not appear, but current needs a path. So current will flow through this freewheeling diode only, and this voltage will be zero for this whole duration. So from this waveform we can calculate the average output voltage. V naught average is equal to 1 upon 2 pi alpha 2 pi Vm sin omega t d omega t. So here average value will be Vm upon 2 pi 1 plus cos alpha. So we can calculate the average value of the output voltage. So that will be Vm is 230 into root 2 divided by 2 pi, okay, into 1 plus cos 50. Can anyone calculate this value? How much? 230 into root 2 divided by 2 pi into 1 plus cos,
85.04 volts.
okay, 85.04. So almost we can say that 85 volt, okay, approx 85 volt. So what will be the current here? This is 85 plus minus 85. So the current will be 85 minus 80. I will be 85 minus 80 divided by 5. So the
0.212 0.21.
no. See, 85 minus 80 means 5. 5 divided by 1 ampere.
1 amp, sir. 1 amp. Sorry, sir.
So this will be the final answer. Is it
Sir,
yes, you can ask. Ask.
sir, semiconductor half cycle also negative cycle.
See, negative cycle, what is happening, since one is open circuited, this will be open circuited, so I am removing this one. Okay. So what will happen? T1, T2 we are firing at alpha. T1, T2 we are firing at alpha. So alpha to pi this will conduct. After pi this will reverse bias. But since path is not here and current we are saying that it is a continuous current. So this will turn off, this will turn off. So this highly inductive current will flow in this freewheeling diode. Since even if we will fire this one also, so since this is not there, so this will not complete a path. Okay. So this highly inductive current needs a path. So where it will go? It will follow this freewheeling diode. Okay. So if it will follow this freewheeling diode, this whole portion will be zero. In case of semiconductor, what was happening? Here to here one waveform was coming. Okay. Pi plus alpha to 2 pi. But since here this is open circuit, so this negative portion, this second side portion will not appear here. Is it clear now? Is it clear? Am I audible?
Yes, sir. Yes, sir.
Okay, okay. Should I move to the next question?
Yes, sir.
Oh. So, so this is a good question. Some information is given in the question. Like this is a single phase half controlled converter. These two are the thyristors and two are the diodes. Okay. And Vs is sinusoidal source voltage. So while nothing value is given here, the value of percentage THD in source current, where Vd0 is DC output at alpha. So these two informations are given. V0 is equal to Vd0 by 2 and Vd0 is equal to V0 at alpha is equal to 0. So with these two information only, nothing is given, no data is given. So with these two information only, we have to calculate the THD in the source current. This is the source current. So we have to calculate the THD. No like numerical values are given. One is given that output current is ripple free current. These two data are given. V0 is equal to Vd0 by 2. This is one information is given. Here Vd0 is V0 at alpha is equal to 0. So what is V0 value? V0 is equal to Vm upon pi 1 plus cos alpha. This is output voltage equation. And what is Vd0? So Vd0 is V0 at alpha is equal to 0. So Vd0 we can write as Vd0 is equal to V0 at alpha is equal to 0. So alpha 0 means 2 Vm upon pi. Okay. So now with this relation, we can calculate the value of alpha. So V naught is equal to Vd0 by 2. We can apply. So Vm upon pi 1 plus cos alpha. This will be equal to this Vd0 by 2. So this Vd0 by 2 means Vm upon pi. Okay. So from this equation, we can calculate the value of alpha. So 1 plus cos alpha is equal to 1. Cos alpha is equal to 0 and alpha is equal to 90 degree.
90.
So from this 90 degree, we can calculate the value of THD. How we can calculate? IS1 we know. IS1 is equal to 2 root 2 by pi cos alpha by 2 into I naught. And IS is IS1 by IS I am doing here. So IS will be pi minus alpha by pi into I naught. So I naught will cancel.
0.707.
You are getting 0.707. You can calculate
Yeah,
the
IS.
final THD.
IS.
THD how much?
IS.
Okay. You are how IS1 by IS how much you are getting? 0.707. This ratio you are getting 0.707. Okay, so then we calculate. So 2 root 2 by pi into cos alpha by 2 means cos 45. Alpha is 90, alpha by 2 45. Here pi minus alpha by pi. So alpha is how much? Pi by 2. Pi minus pi by 2. So it will be under root 1 by 2. Is it clear to all?
Yes, sir. Yes, sir.
So it will be 4 by 5. This root 2 will go at top. So 4 by pi into cos 45. You can say that 2 root 2 upon pi.
0.9.
Okay.
0.9.
0.9. Okay. So THD we can calculate. THD will be 1 by, this is called distortion factor. So THD will be under root 1 by df square minus 1. Okay.
0.483.
Okay. 0.48. How much?
0.483.
48. Okay. So 48.3% we can say that the THD is 48.3%. Clear? Like all of you know
Like,
this normal full bridge rectifier also for some value of alpha, like in some gate question is there. For normal full bridge rectifier, this data is there in some gate question, but same data we are getting here also. Okay. 2 root 2 pi pi when we will get 2 root 2 by pi into I naught. So IS1 is equal to, in full bridge converter how much? IS1 is equal to 2 root 2 by pi into I naught. IS is equal to I naught. Okay. So for full bridge converter, THD will depend on alpha or not? Can anyone tell? Normal full bridge converter. Normal full bridge converter is there. THD will depend on alpha or not? This is a full bridge converter. Full converter. So here what will be the source current? Fundamental source current will be 2 root 2 upon pi into I naught, and source current how much? I naught. So always distortion factor will be 2 root 2 upon pi. So what we can conclude that in full bridge converter, this distortion factor is independent of firing angle. Is it clear?
okay, sir.
But here our distortion factor is, one second. Here our distortion factor is depending on the alpha. Is it clear? Clear to all?
Yes, sir.
So see, one question can be framed how? Like it can be framed like this. Let's say question like, let's say THD in full bridge converter. Okay. Converter. So we can say that THD in semi converter same as full bridge converter. So what will be the value of alpha? In that way you can frame. So a statement will be, if semi converter is given, the THD of the semi converter is same as the THD of a full bridge converter, then what will be the value of alpha in case of semi converter? Okay. So in that case, in reverse way, if we'll do the calculation, we'll get the value of alpha is equal to 90 degree. Is it clear?
Okay, sir.
Clear to all? Like in this way, you have to develop your thought process, like how different type of question can be framed. Like GATE means aptitude test. Aptitude test means some data will be given, and from some given data, you have to calculate some other data. Okay. Like some reverse way, some data will be given. Using that data, you have to calculate some other variable. Here, let's say THD is given like already 48.3%. Then what will be the value of alpha? They can be asked. So in reverse way, we can calculate that value. Is it clear to all?
Yes, sir.
Okay, okay. So I think one last question is there. Okay, this is already asked in the gate. Maybe we have gone through this question. So this is RE load is given, battery charging load. This is R and this is EMF E. Okay. So we have to calculate the charging current of the battery. So in RE type, let's say highly inductive load will be there now, then E will not matter. Highly in case of highly inductive load. Okay. But RE load will be there. Then we will draw the waveform first. Say this is output voltage. Normally output voltage will be like this, but EMF is there. Okay, this is a EMF. So thyristor can be fired only when they are in the forward bias direction. Okay, so when V will be greater than E, this is the voltage, source voltage. Output side it will be like this one. So when V will be greater than E, then only we can say that the thyristor is in the forward version. So it can be fired from here to here only. And one statement is given triggered by a constant DC signal. It means continuous gate pulse we are giving to 1, 2, 3, 4. Okay. So if we are giving the continuous pulse means it will work like a diode. Continuously it is turned on. Okay. So whenever it will be in forward direction, forward bias mode, it will conduct. Like we are providing continuous gate signal. The sine wave is there. Continuous gate pulse is given. So whenever it will be in forward bias, then it will conduct. Whenever it will be in reverse bias, then it will not conduct. So positive half cycle this T1, T4 conduct. Negative half cycle 2, 3 conduct. Okay. So now we can calculate the value when it will be forward bias. So this is the crossing point theta 1, theta 2. So E value is how much? E is equal to 200 volt. 200 volt. And this V is equal to how much? 230 root
3.54, sir, answer.
omega t. How much?
3.54.
This one?
Uh,
No. This is the correct answer. 11.9.
okay. Okay, sir.
So see how we can calculate. So current will flow from when it will listen again. What is happening here? All thyristors are getting a constant DC pulse. So constant DC pulse means it will be continuously on. Whenever it will be forward bias, then it will conduct. Okay. Let's say this is only resistive load. E is not there. So if E will be not there, what will be the output voltage? Output voltage will be like this one. Output voltage will be like this. Okay. If E will not be there and all four thyristors will be there and constant DC pulse, constant pulse we are giving to all the thyristors, in that case it will be a diode bridge rectifier. Is it clear? Because we are giving constant pulse. Constant pulse means whenever that thyristor will be in forward bias, then automatically that will conduct because pulses are given for entire duration. Okay. So but here if you will see when V will greater than E, then only this will come as forward bias. So what other information is given? Oh, 1 second. That SCR is if SCR2 gets open, so this 2 is open. So this 2, 3 will not conduct. So only positive half cycle waveform will be there. And waveform will be from theta 1 to theta 2. Theta 1 to theta 2. And this side, no current will be there. This is pi. This is waveform of the current. Is it clear to all? I know. Otherwise I will explain again.
So clear, sir.
Okay. So what will be the theta 1 value? 230 root 2 sin omega t. This is to be equal to 200. So can anyone tell what will be the value of this theta 1? Sin inverse 200 by 230 root 2. So in this kind of question, I will suggest you all do all the calculation in radian value. Okay. Where actual value is needed, we have to calculate all the value in radian. So we can put the calculator in radian mode. Radian mode we can put. So sin inverse 200 by 230 root 2. 200 divided by 230 into root 2. How much? 0.662 radian. Theta 1 is equal to 0.662 radian. Is it correct? And what is value? Pi. So theta 2 will be pi minus 0.662 minus. So 2.479. Everyone is getting this value?
Yes, sir.
Okay. So now what will be the current? Current will be I naught will be, so this will be 1 by 2 pi, and Vm sin omega t minus E, theta 1 to theta 2, Vm sin omega t minus E divided by R, d theta or d omega t. So this will be the current. Since current is flowing from theta 1 to theta 2, and what will be the current equation? This is V naught minus E by R. So V naught is Vm sin omega t, Vm sin omega t, here to here, Vm sin omega t minus E by R. So we can write that 1 upon 2 pi R. This will be Vm we can take outside, inside only we can do 1 upon 2 pi R, and here it will be Vm how much? 230 root 2, and sin omega t integral will be minus cos integral minus E theta 2 minus theta 1. Can anyone calculate this value? We are getting this or not? 11.9. 230 to root 2 minus cos omega t theta 1 to theta 2 minus E into theta 2 minus theta 1. So we can say that 1 upon 2 R how much? Internal distance to 1 upon 4 pi into 230 root 2 into cos theta 1 minus cos theta 2. So cos theta 1 how much? Cos 0.662 minus cos 2.479 minus E how much? 80 into theta 2 minus theta 1. 0.479 minus 0.662. Can you calculate this value? I'm also doing calculation. So 1 upon 4 pi into 230 into root 2 into cos 0.662 minus cos 2.479. Anyone is getting the answer? 230 into root 2 cos. Minus 80 into 2.479 minus 0.662. Getting 20. It's incorrect, I think. Anyone is
Equal
getting
to
we are getting
200, no, sir.
we are not getting this answer. 11.9.
Sir, equal to 200, sir. You taken 80.
Okay, E is 200. Okay, okay. What is the 80? I think by mistake, 80 is not there anywhere. So this is
The previous problem, sir, that one.
previous problem out there. Minus 200. How much we are getting? If calculation mistake will be there, answer will not be correct. 11.9 is correct. Minus 200. So this will be 11.9. Everyone is getting this answer? Is clear to all?
Sir, clear, sir.
Okay. So this was the last question. So see, single phase almost I have taken all the get previous year question. Full bridge I have taken. So half bridge converters are remaining. Half bridge means only single thyristor will be there. So this type of question maybe I am planning to start three phase from next class. Okay. So three phase I will start with some first same. Otherwise, should I cover this first? This one I have left. This single phase like half bridge converters are there, na? So should I? This is easy only. Should I cover this first? Then I will start to the three phase. Is it okay?
Yes, sir.
Yes, sir.
First I will cover this remaining part. This type of previous year question based on only single thyristor, or we can say that half bridge rectifier we can say. So this kind of question I will cover in the next class. Or first some questions I will cover. Then I will give a starting of three phase. Okay. So three phase will
Three
be
phase
there.
formless also, sir, that one.
Yes, you can ask.
Three phase formless, sir, that circuit. Full converter semiconductor.
So I will start with three phase basics. Okay, how to draw the waveform. Here main thing will be drawing the waveform. Okay. So I have already prepared some graphs and all related to this. So short tricks I will tell how to remember the graphs and how to be confident in drawing the graphs for three phase. So I will start with three phase half wave converter first, like three pulse converter. Every converters I will do the Fourier analysis. Okay, like I have done for single phase, for three phase also I will do the Fourier analysis for all. Then it will be more clear. And then six pulse, okay, and then three phase full converter. Okay, so here in all this analysis we will analyze the circuit term of time. Okay, peak inverse voltage, all the parameters we will do here. Okay, and some good great questions are there, like how, like one case question is there, like how for how much duration this circuit will be in reverse bias, or that type of question. So all those pulse and waveform I will explain in detail. Okay,
Sir?
it will be one-to-one discussion, so it will be more clear.
Okay.
Like we will get confident in three phase waveform, either six pulse or three pulse. Okay.
Okay. Sir?
Yes, you can ask.
Sir, in previous problem, 3 thyristors, 1 diode is there, no, sir?
Okay, you can ask. Other scenario you want to?
Previous problem, sir. Previous. Yes, sir. Here, if we take T1 at D3, sir.
Okay, T1 you want at D3.
Yes, sir.
Okay, and all these three should be diode.
Yes, sir.
Okay. So this is diode, and this you want as thyristor.
Yes, sir.
Okay. Let's say this is source voltage, Vm sin omega t. So this we are firing at pi plus alpha, 3 pi plus alpha, like that we are firing this one. Okay. So this is the source voltage. At starting only what will happen? This D1, D2 will become forward bias. Starting only. So it will
Yes, sir.
conduct like this one. Again,
180 degrees
we
up
are
to.
firing this one at pi plus alpha. This one pi plus alpha. Again 3 pi plus alpha. Like this it will have. So here to here what will happen? It will be 0. Again it will be like this one. So this will be 0, pi
plus or
2 pi. Is it clear?
yes,
We
sir.
can derive the average output voltage. I think that will be same here also. So see, this is Vm sin omega t. Okay.
Yes, sir.
Vm sin omega t 0 to pi. Period will be 1 by 2 pi. Okay. Plus pi plus alpha to 2 pi minus Vm sin omega t. Okay. So Vm I am taking outside. Vm upon 2 pi and this first part will be minus cos omega t 0 to pi, plus the second will be cos
Vm
omega
cos
t
omega t. Sir.
pi plus alpha to 2 pi.
Okay.
So this first term will be how much? Vm upon 2 pi, and here will be cos pi minus 1, so minus minus plus 1 plus 1 plus 1. Here cos 2 pi how much? 1 minus cos pi plus alpha. So cos pi plus alpha how much? Cos pi plus alpha.
Minus cos
All
alpha.
kind. So minus minus plus. So it will be
Okay.
cos alpha. So Vm
Same.
upon 2 pi 3 plus cos alpha. Same thing we are getting. Because waveform is same. Area under the curve is same here also, na? Like,
Sir.
is it clear?
Exactly. Yes. Yes.
Okay. Okay. So thank you all. Next class I will do some half bridge rectifier single phase. Then I will some starting I will do for three phase. Okay, like some waveform techniques I will start for three phase. Okay. So thank you all. We'll meet in the next Monday. Thank you.